Hello everyone, I'm really happy to be here. I mean, I try to come every time since 2015, I think, or 16 was the first time. So I'm really happy to be again in Kiev. So I'm working now with Nim since 2 years. It's called Nim. Nim comes from name, like anonymous. Inside of anonymous, you have the name, and so or pseudonymous, and we took the Nim as the name of this project. So basically, what we're focusing is on privacy. The existing internet, and especially the crypto space, is built on transparency, and this is for a good reason. But on top of transparency, we think that it's very crucial, and it's actually part of the concept of how we thought since the 80s we should build internet. The privacy should come on top of a transparent network. But to build this, you actually need to build first an anonymous layer, and that's what we're trying to achieve here. So the team, you see here quickly the team, we have like great minds. Harry is a former W3C member, and he's a researcher former researcher at NYM. Dave, he's the CTO, he's a former Facebook, and he was actually meant to build Libra, but he sold his company ChangeSpace to Facebook, but then quickly left and joined us. And Claudia Diaz, which is like one of the brains of the Mixnet. She's a professor in Leuven about networks and anonymous network. Just myself, I'm a Swiss expert in crypto companies. I built 2 brokers and some other companies in Switzerland, and so I know the legal background in Switzerland, able to set up ICOs and licenses and so on. All right, so what we think there's few important things that are going to happen. First is that privacy is going to be a key element in the next internet. We had some great presentations which show us how the internet is going to move from Web 1 to 2 to 3, but in there, privacy is going to be key. We see that there's a big beefing up of surveillance. Surveillance not just in terms of like surveillance of state, but a mixture of companies and states. So you have like theories like what the capitalism of surveillance is. That was defined in the more US side. In the Chinese side, there is like a deep state surveillance. And with COVID, it went really, really further down. So when we are working on transparent systems where we can see everything which is happening, we need to think of privacy as a very serious thing, because otherwise we have a huge problem. So, oops, here. So we think that internet on the privacy side is broken, which internet was built completely transparently, exactly the same as Bitcoin was built completely transparently. And like the previous presentation on the layers of internet showed, blockchain applications are built on top of several layers of communication, and those ones are very transparent. So for example, the metadata, the IP addresses of who is sending what to who is actually visible on the internet. So even if you're using Bitcoin, which is pseudonymous, or even if you use Monero or Zcash, which are anonymous transactions, the blockchain itself lives on a transparent network where you can see who is broadcasting addresses and where you can do timing attacks, and you can try to correlate things together. So you could actually de-anonymize part of the who is sending coins to who based on the traffic network traffic analysis below. When we try to build privacy, there's few things that we try to do. We try to build VPNs. This is a first good step, but still it doesn't provide anonymity. It just forwards, it hides your IP address, and it shows another IP address. and actually you have to trust the VPN provider. And Tor, you might know, is a peer-to-peer networks of computer that you can use. And when you are using this, you also gain a certain amount of anonymity, but it doesn't provide you defense against someone who can see the whole network. So what we're trying to achieve is basically a protection against global adversaries. So we believe there is a high demand for privacy. We see that the Tor usage is growing. We see that even today, for example, it was announced that Facebook was deleting all the facial recognition database that they have. They were deleting this, and Clearview AI was forced to also remove some part of these databases. So there's a clear push for more privacy. But actually, the privacy until now has been built on a business model which there was no business model for privacy. It was based on open source software, which is good, but the network which are being used for privacy, like Tor or Signal, for example, are provided for free. So free meaning someone still has to pay, and so it's very altruistic. Tor was founded by the US Army, actually, and they got funding from foundations, and Signal also has funding from the founders of WhatsApp, which founded Signal. So, which are paying Signal. So basically right now, these examples of projects are projects which are being funded by donations, and we believe that the Web3, the crypto economy is providing solution to build incentivized networks. And that's what we're exploring also here. Oop. So the idea is that we're going to build a Mixnet. A Mixnet is a set of computers which is routing traffic, and we will see how it's going to happen. It's routing traffic, and it allows to build anonymity. And this is a concept which dates from the 80s, invented by David Chaum. With this, we're going to add a token, which is not a cryptocurrency. It looks like a cryptocurrency, but it's not. We don't consider as it. It's under Swiss regulation, it's a utility token. So it represents the value of the network, and it's actually used between the different participants of the network. And we'll see this participant of the network. And then the credentials, this is actually the small piece of code that you are going to use to access the network. So it's a Nim credential actually allows you to show that you have purchased bandwidth on the network. So the Nim Mixnet, that's a key technology. And until now, there was never a functional Mixnet. Functional somehow, yes, but never used at large scale. And we hope to solve that problem. So what is a Mixnet? So first, exactly like Tor, you can have multiple hops. You have 3 hops. So you're sending data in the network, and it goes through 3 hops. But the difference between Tor and the Mixnet is that every packet in the Mixnet takes a different route, while on Tor, every packet takes the same route for 5 or 10 minutes. The second thing that we change is that we add cover traffic. That means we add fake packets. So when you are looking at all the packets that are going through the system, you don't see the difference between a real packet and a fake packet, because one very important thing is that these packets all have the same size. We use a protocol called Sphinx to build packets which have exactly the same size, so you cannot distinguish between packets from the real packets and the damaged packets. Then, on Tor, one of the biggest attacks that you can see is called timing attacks. So how does it work? If you are big adversaries like the NSA or like the Russian intelligence, whatever, you can have a lot of nodes in the system of Tor, which they do, and you can look at the entry point and the exit point, and you look how much time it takes for the data to go from one side to another. And then you can see, oh, indeed, this data is from this guy. So this is one attack. So what we do here is we add a time of obfuscation where some of the packets will be slowed down. So if you're sending a file which is divided in 5 different packets, let's say, those 5 packets will use different routes and will not arrive at the same time on the other side. So it's very difficult to correlate, or it's almost impossible to correlate based on the time. And because we use a Mixnet, so it's not a peer-to-peer network. It's actually something we can. You will see the structure, and we can scale horizontally the traffic. So here you have like how a VPN look like on the top. So you have normal internet traffic that goes through to the nodes of the VPN, and it goes out to the service provider. If you compromise the node in the middle, you can relate the two things. So this can happen. Either a VPN gets hacked or government has access to the VPN, and they can exactly see who is sending data to who. Tor is a bit more complicated. You send a certain type of traffic through the system, but there is one route, and the pattern, the pattern of the traffic is the same at the entrance and the exit. And then we go like a deep dive on how the mixed network is working. So there's a lot of things happening. So the user agent is the client. It can be you, your cell phone. It's the start point. And you want to discuss to a service provider. So a service provider could be an API, a backend, could be, so in terms of the crypto space, what we think is like you have a Bitcoin wallet over there and you have a Bitcoin node here. And the Bitcoin node is ready to serve the client, but we don't need to know what is the IP address of the user. To broadcast the transactions, we don't need this. We just need to receive a valid Bitcoin transaction. That's enough. So inside the computer of the person who is sending, you have normal traffic. So this is normal traffic that goes through the Nim client here. And the Nim client will actually put every traffic into standardized Sphinx packets that will then be routed to the network, but each of them will have a different way. And if we have more users, basically, if we want to increase the capacity of the network, we just add layers of 3 mixed nodes, which will add up the capacity of the network. And then when it goes out, so there is the mixing, so all the traffic from all the users get mixed by the same servers, and then it goes out to the service provider, who also has a client, and then can read these packets and decrypt these packets for himself. All right, so there's a token, that's the second part. So the token is used to get all the resources together, because those nodes are not going to be run by us. Those nodes are run by member of the community, and they are going to be incentivized. They're going to be incentivized based on the actual traffic that they are mixing. So the more traffic they're mixing, the more people who are using the nodes are paying for that, they will get the rewards. So they will actually, we have mixed nodes, and we have a small blockchain on the side, which is based on Tendermint right now, because it's the most easy and off-the-shelf blockchain we found that was working. So it's a small blockchain which actually contains the ledger of the Nim token. We are not bound to Cosmos. It's something that we could change potentially in the future to another blockchain or to a state channel, for example, like it was explained before. But we needed somewhere easy to represent the Nim token. So this is maintained by a set of validators, then the mixed nodes will actually do the work and will provide proofs that the mixing is done. So how do we provide this proof? And actually we send specific packets, which are rewards packets, through the system, but the node doesn't know the difference between a normal Sphinx packet, a dummy Sphinx packet, or a reward Sphinx packet. So he needs to process it correctly. If he processes correctly his reward packet, then he can actually get the money of this. So what we think about the Nim token is actually it represents the value of the Nim token will be the value of the privacy network, that the use of the bandwidth. So basically it will be maybe for 1 gigabyte over 24 hours, the cost of the Nim token will represent something like this. So yeah, we already went a bit on the users, on the type of actors of the network. So you have the users, the ones which are actually sending packets through the system. So they will be paying, or they will the token, the usage can be paid for, but it's a paid thing. Then you have the validators, which are maintaining the ledger and the economy, the incentive between all the actors who are putting resources in the network. The service provider are on the other side. They are the one who are providing a service within the NIM network to the users. And finally, the mixed nodes, which are providing the core technology in there. Additional on the Mixnet itself, we added a system of credentials. So the system of credential, it's called Coconut, and it has been developed by some people of the part of the team, and is actually a system of zero knowledge proofs. But these zero knowledge proofs have one specific thing: is they can be re-randomized. So you can receive a proof that you've paid for the network, and you can change it locally and show it to someone, and it's still valid, but they cannot share it between the two. So it's re-randomizing of credential. So these credential, the basic function is just to show that you have paid for traffic, for anonymous traffic, but we can add, the service provider can add other attributes on there. So within the network, you can actually build up things like a KYC, for example, with some attributes can be built at the protocol level directly. Here we have a flow of the Nim token. So the basic idea here is that if you are a user, the first thing you need to show is to show if you have access to credentials. And if you don't have credential, you would actually buy tokens. So with Bitcoin, for example, you will buy tokens, and then those tokens you can redeem against credentials immediately, and those credentials you can be using it instantly. And then it's the NIM blockchain which gives the topology of the network. Where we are right now, so we have a testnet which is 5,000 nodes already. So currently is the largest Mixnet running, even though it's just a testnet. We are going to go to mainnet by the end of the year, in December. That's the objective, so it's coming very, very soon. We are now in the phase where we are doing internal audits. We have hired, we just got joined in the team by Chelsea Manning, that is doing part of the audit, and she's been very much exposed in the US because of her knowledge. So she's very useful for this. And then we'll focus mostly on the cryptocurrency side, providing support for different types of wallets. Basically, you can put any kind of traffic. It's generic traffic in there. So we will focus first on the crypto economy, because this is where privacy matters at most for a lot of us. And then we'll extend to other things. So we believe that, yeah, if you have a transparent network, you first need to build an anonymous layer, and then you can actually enable real private transactions or communication, and this is what we're trying to achieve. Thank you very much.